Okay, for this video we're going to do some neutralization reactions, and I've taken hydrochloric acid and put it in here with an indicator that will show when an acid is added. Hopefully it'll work here. We have to add enough base to make it just go past neutral. Oh, maybe it's not going to work. Okay. Well, anyway, we put an acid and a base together, and it's the first reaction up here. You can watch the video that's linked on Moodle. It has the actual color change that happens. Okay. So what we need to remember when we have a base is it always ends in OH. When we have an acid, it always starts with H. So what happens is those two things come together and make HOH, which is the same thing as water. Okay, so that's always one of our products with a neutralization reaction. Then what happens is whatever's left combines together and makes our other product. So in this case we have Na, which is +1, Cl, which is -1, so we get NaCl. Now this is a balanced equation already. We know that water is a liquid. We know that NaCl is going to be dissolved because it's all liquid in this case. Okay. If you go down, that was our demonstration. An acid, again, remember, always has an H. And then our base always has an OH. So you can look at this sheet, okay, and follow the examples, and we're going to go through those. Again, acid here, base here. So we have an HOH. Does not matter if you have 15 H's or 1 or 15 OH's or 1. It's going to make water. So it's always HOH, and we'll balance the rest out later. So then we have ammonium and nitrate. Ammonium is a +1. Nitrate is a -1. So again, when we write our formulas, those cancel. So we have NH4 NO3. And again, that's going to be aqueous because it's dissolved, and water is a liquid. Okay. Our next one, again, we have our H here and OH here. Again, here we have more than one H. That does not matter. Okay, you're still going to write HOH or water because that is a product, which is a liquid. We're then going to take our K and our SO4. K is a +1, SO4 is a -2. So we end up with K2SO4. Again, this is aqueous because it's dissolved. Now we balance our equation. We have 2 H's here, so we need to put a 2 here, so we have 2 H's here. Then we're going to have to put a 2 here to give us 2 OH's because we have 2 OH's there, and we need 2 potassiums, and we have 2 potassiums. Again, does not matter how many H's you have over here, you always write OH. Okay. Next one, H and our OH here. Again, you only write water. We will balance them later. Then we take our sodium and our phosphate. Sodium is +1, phosphate is -3. So that means we're going to have 3 sodiums for every 1 phosphate. Again, this is aqueous because it's dissolved. That's supposed to be an A, and this is liquid. Okay. Now we look over here. If we have 3 H's, we have to have 3 waters. So then that means we need 3 OH's, and we have 3 NA's. So that balances out both of our sides. And that's your neutralization reactions.